Hello viewers, in today's class we are going to discuss an important type of indefinite integrals in which we have to integrate functions like 1 over q1 times square root of q2, right? Where q1 and q2 are quadratic polynomials, right? So here we are taking an example for illustration. So let us find out this integral where we have dx over x square plus 1 times the square root of x square plus 2, right? So if we compare this integral with this one, then we can see that q1 is x square plus 1 and q2 is x square plus 2, right? And both these are quadratic polynomials, right? So whenever we encounter an integrand which is of this form, where q1 is a quadratic polynomial and q2 is another quadratic polynomial, then we can see how we can uh, integrate functions of this kind. So here the first step is to take x is equal to 1 over t, right? So first of all, we'll put x is equal to 1 over t, that is, we'll introduce this parameter or variable t, right? So x is equal to 1 over t. Now let us differentiate x with respect to t. So we'll get dx over dt is equal to d by dt of 1 over t, that is d by dt of t raised to minus 1. So this is minus 1 times t raised to minus 2, that is minus 1 over t square, right? So dx over dt is minus 1 over t square. So dx is now equal to minus dt over t square, right? So the first step is to take x is equal to 1 over t, and then we find dx is equal to minus dt over t square, right? So now this integral I in the form of this parameter t, now it becomes dx is replaced by minus dt over t square, and in the denominator we have x square. So this is 1 over t square plus 1, and here we have square root of 1 over t square plus 2, because x is 1 over t. So now let us simplify this integral. So we have minus dt over t square, and here we have taking the LCM, we have 1 plus t square over t square, and here we have square root of 1 plus 2t square over t square, right? So now I can be written as integral, we have dt over t square, and here we have the negative sign, and here we have 1 plus t square over t square, and here we have square root of 1 plus 2t square and divided by t, right? Because the square root of t square is t, right? Now this t square and this t square get cancelled, and we can take this t to the numerator. So we have minus, here we have t dt, and we have 1 plus t square, and here we have square root of 1 plus 2t square, right? So viewers, by taking x is equal to 1 over t and dx is equal to minus dt over t square, we have obtained this integral, right? So our next step is to substitute, say z is equal to 1 plus 2t square, right? So we can take z is equal to square root of 1 plus 2t square, right? So the first step is to take x is equal to 1 over t, and after getting all these steps, let us substitute, or let us introduce another variable z, that is equal to square root of 1 plus 2t square, right? So we can also write it like this: z square is equal to 1 plus 2t square. So now differentiating both sides with respect to t, we have d by dt of z square, and here we have d by dt of 1 plus 2t square. So here the derivative of z square with respect to z is 2z, and then by chain rule we have dz over dt, and here the derivative of 1 is 0, and we have 2 times the derivative of t square is 2t, right? So this 2 and this 2 get cancelled, so we are left with z dz, and here we can take this 2 to the denominator of z dz, and here we have t dt, right? So this t dt can be replaced by z dz over 2. So now this integral in terms of z can be written as negative here, and t dt can be replaced by z dz over 2, and here in the denominator we have 1 plus t square. So now see, from here we can write z square minus 1 is equal to 2t square, and t square can be replaced by z square minus 1 over 2, right? So here we can write 1 plus t square is replaced by z square minus 1 over 2, and for square root of 1 plus 2t square we can write simply z, right? So now this z and this z get cancelled, and we have I is equal to minus, here we have dz, and here we have half outside the integral sign, and here we can take the LCM, so we have 2 ones are 2 plus z square minus 1 over 2, right? So this half is taken outside the integral, so now this 2 and this 2 get cancelled, so we are left with minus, and here we have dz over z square, and 2 minus 1 is 1, right? So now we have this simple integral, right? So now viewers, here we have minus integral dz over z square plus 1. So this can be written as here 1 square. So now we have a simple integral, that is the dx over x square plus a square is equal to 1 over a tan inverse x over a, right? So we know this standard integral, and if we compare this integral with this one, then see here we have minus, and the value of a is 1, and for x we have the variable z. So now we have minus, and here we have 1 over 1 because this is 1 over a is 1, and we have tan inverse x over a. So x is z and a is 1 and c is the constant of integration, right? So we have 1 over 1 as 1 simply, so we have minus tan inverse z plus c, right? Now see, here we are having the final answer in terms of z. So let us convert z into t. So here we have z is equal to square root of 1 plus 2t square. So we can now write minus tan inverse square root of 1 plus 2t square plus c, right? And now further replace t by 1 over x, because x is 1 over t, so t is 1 over x. So now I can be written as minus tan inverse, and we have a square root of 1 plus 2 over x square, because t is 1 over x. And here we have c as the constant of integration. So I is minus tan inverse square root of x square plus 2 over x square plus c, that is minus tan inverse square root of x square plus 2 divided by x, because the square root of x square is x, and here c is the constant of integration, right? So viewers, the indefinite integral of this function 1 over x square plus 1 times square root of x square plus 2 is given by minus tan inverse square root of x square plus 2 divided by x plus c, right? So this is how we can solve these type of indefinite integrals, in which we have the form 1 over q1 times square root of q2, where q1 and q2 are quadratic polynomials.